Okay, children, here we have in this video chemical stoichiometry. What is chemical stoichiometry? Let us consider this chemical equation for the chemical reaction between zinc and sulfuric acid. Zinc reacts with sulfuric acid to form zinc sulfate and hydrogen gas. Now, this equation gives us many significances. Suppose one significance can be one atom of zinc reacts with one molecule of sulfuric acid to form one molecule of zinc sulfate and one molecule of hydrogen. It also signifies this thing that 1 gram atom of zinc or 1 mole of zinc reacts with 1 mole of sulfuric acid or 1 gram molecule of sulfuric acid to form 1 mole of zinc sulfate or 1 gram molecule of zinc sulfate and to form 1 mole of hydrogen or 1 gram molecule of hydrogen. So 1 gram molecule, this is 1 gram molecule, and this is also 1 gram molecule. And since they are also mole, these all are also means mole. Another significance is since atomic mass of zinc is 65, molecular mass of sulfuric acid is 98, and zinc sulfate molecular mass is 145, and here molecular mass is 2. So we can say also this thing 65 parts by mass of zinc reacts with 98 parts by mass of sulfuric acid to form 145 parts by mass of zinc sulfate and 2 parts by mass of hydrogen. If we can also say this thing 65 grams of zinc reacts with 98 grams of sulfuric acid to form 145 grams of zinc sulfate and 2 grams of hydrogen. So different interpretation we can have. Now let me tell you one result which comes from mole concept, very important to remember. 1 mole of any gaseous substance, 1 mole of any gaseous substance at normal temperature and pressure, which is called NTP. 1 mole of any gaseous substance at normal temperature and pressure occupies 22.4 liters. Occupies 22.4 liters. You see, normal temperature is 0 degrees Celsius, and normal temperature, is 1 atmospheric pressure. So, at that condition of temperature and pressure, 1 mole of any gaseous substance occupies a volume of 22.4 liters. This is a result that you need to remember. This we can show it, we can prove it from mole concept. Now, so since this is 1 mole of hydrogen, it will also mean 22.4 liter of hydrogen at NT. So let us write a question here, do a question here. This question is that how many grams of zinc will be required, how many grams of zinc will be required to produce say 100 liter of hydrogen at NTP. Suppose this is a question. How many grams of zinc will be required to produce 100 liter of hydrogen at NTP? So when you have to first write the equation, and from the equation we can write down this thing that 22.4 liter at NTP is obtained from 65 gram zinc. So 1 liter will be obtained from 65 by 22.4 gram of zinc, and 100 liter will be obtained from 65 into 100 by 22.4 gram. So this you simplify, that will be the answer. Suppose there is another part to this question. Suppose another part to this question is how many grams of sulfuric acid will be required how many grams of sulfuric acid will be required to prepare 100 liter. So since we have to find sulfuric acid amount, we can keep it in the right side. So same as before, 22.4 liter at NTP is obtained from, we can say, 98 grams of H2SO4. So 1 liter will be obtained from 98 by 22.4, and 100 liter will be obtained from 98 by 22.4 into 100. So we can find out amount of sulfuric acid that is required. So now let us try to find out that discuss what is limiting reagent. Let us consider this reaction where water is being produced from hydrogen and oxygen, and we can see from the balanced chemical equation that 4 grams of hydrogen combines with 32 grams of oxygen to form 36 grams of water. This is the ratio, this is the proportion in which hydrogen and oxygen combine. Okay, now suppose in a certain experiment, we are taking 4 gram of hydrogen and say 100 gram oxygen. 4 gram and 100 gram of oxygen, and suppose we are asked how much water will be produced. Now we know that 4 gram of hydrogen reacts with 32 grams of oxygen and it will form 36 grams of water. Now since we are taking here 4 gram of hydrogen and 100 gram of oxygen, so since we know 4 gram of hydrogen can only react with 32 gram of oxygen, so the remaining oxygen will be in excess, will not be reacting. Out of 100 only 32 grams will be reacting and rest will be not reacting, will be in excess. So if we have 4 gram of hydrogen with 100 gram of oxygen, 4 gram of hydrogen will only react with 32 grams of oxygen and 36 grams of water only will be produced. So it is not like this that if we take oxygen in more amount, we get product in more amount. Here we are seeing that amount of product formed, it depends on the amount of hydrogen that we are taking. Now oxygen is in excess. And you should always remember that amount of product formed depends on the amount which is in less amount. It depends on the reagent which gets completed. When we have 4 gram of hydrogen with 100 gram of oxygen, 4 gram of hydrogen will totally react, but oxygen will be left behind. Oxygen will not totally react. So since oxygen is in excess and it is hydrogen which is reacting completely, and then that's why this hydrogen will be the limiting reagent in this case. Hydrogen is a limiting reagent, and as already said, amount of product formed will be 36 grams only. So amount of product formed is depending on the limiting reagent. That's why so we can say that limiting reagent limits the amount of product formed. That's why they are called limiting reagent. Okay, now suppose in another experiment, we are having, say, we are having, say, 32 gram of oxygen and say 100 gram of hydrogen. In another experiment, we are taking like this: 32 grams of oxygen and 100 gram of hydrogen. Now, according to the stoichiometry, we are seeing that 32 grams of oxygen reacts with 4 gram. So this 32 grams of oxygen will also react with 4 gram, and rest 96 grams of hydrogen will be left behind. 96 grams. So in this situation, it is oxygen which will completely react. Completely react, and of course we will get 36 grams of water only. So here hydrogen will be remaining in excess, oxygen will totally react. Okay, so when we have 100 gram of hydrogen and 32 grams of oxygen, then this 32 grams of oxygen is a limiting reagent. So suppose a question which involves limiting reagent is suppose we have, say, 10 gram hydrogen we have, and it is made to combine with, say, 10 gram oxygen. 10 gram hydrogen is made to react with 10 gram oxygen, and what will be the amount of water produced. So to find the amount of water produced, you have to find out when we have 10 gram hydrogen and 10 gram oxygen, then which one will be the limiting reagent. Limiting reagent has to be identified first. So we can identify in this way that 4 gram hydrogen reacts with 32 gram of oxygen. You see 8 times. So in this way 10 gram of hydrogen will react with 8 times, means 80 gram of oxygen. 10 gram of hydrogen will combine with 80 gram of oxygen. Now since we do not have that many oxygen, so we can say that this 10 gram of hydrogen will not completely react, because for 10 gram of hydrogen to completely react, 80 gram of oxygen is required. We have only 10 gram of oxygen, so we can say that hydrogen will remain in excess. And which one will react completely? Oxygen will react completely. So oxygen is a limiting reagent. Oxygen will determine the amount of product formed. So we can write here, keeping this thing in mind, 32 gram oxygen produces 36 gram water. So 1 gram of oxygen will produce 36 by 32 gram water, and 10 grams of oxygen will produce 36 by 32 into 10, this much gram of water will be the answer. So children, you need to understand the limiting reagent, and you need to do numericals on limiting reagent. Okay, now children, last topic on this chapter, we have a term called formula mass. We have a term called formula mass. So what is formula mass? Is, suppose we have say methane, or we have sulfuric acid, or we have hydrogen, we have chlorine. These are all molecules. These are all molecules. Molecules are formed by combination of atoms, and since they are all molecules, they have what is known as molecular mass. Molecular mass here is 12 plus 4, 16. Molecular mass here is 98. Molecular mass here is 2. Molecular mass here is 2 into 35.5, that is 71 molecular mass. Now let us consider some ionic compounds. These are all covalent ionic compounds, say sodium chloride, KCl, or say sodium sulfate. These are ionic compounds. Ionic compounds consist of ions. They don't exist as molecule. Suppose sodium chloride has in it sodium ion and chloride ion. Same all these cases. And since they do not have molecules, so we should not talk about molecular mass for all these substances. For ionic compounds, we talk about formula mass. we talk about formula mass. Suppose the formula mass of sodium chloride is 23 plus 35.5, that is 58.5. 58.5 is formula mass of sodium chloride. The formula mass of potassium chloride will be 39 plus 35.5 and so on. So this much we have in this chapter. Thank you for listening to this video. Bye bye and good night.